Welcome you all to the course Database Management System. Mohammad Asifuddin Mondol, Assistant Professor, Department of Computer Science and Engineering, Narula Institute of Technology. And this is lecture number 38, where I am going to cover recovery management. And these are the topics which I am going to cover during my lecture. First, I will discuss about the log-based recovery technique. Then, the category of log-based recovery technique, which is deferred database modification technique and immediate database modification technique. Both of these is going to be covered here, and then I will discuss about the concept of checkpoints. So, what is log-based recovery? Actually, log-based recovery is a most commonly used recovery technique in transaction management system. So, basically, log-based recovery technique is the most commonly used recovery technique which have been used in transaction management system. So, before how log-based recovery technique works, we have to know what is log. Basically, log is a sequence of records which actually maintains or which actually tracks all the records related to the update operation on the database by a transaction. So log is basically a sequence of records which maintains and tracks all the modification activity that has been performed on a particular database by a transaction. That means whenever a transaction perform the update operation, means write operation, then at that point of time the recovery component of the database management system maintains a log record for each and every update operation, write operation performed by every transaction. So log is basically nothing but a consist of set of records. Actually, this record has been created whenever transaction perform the write operation or the update operation in a particular databases. And the log records, after creating the log records, this log actually stored in stable storage. Already we have discussed what is stable storage in my just previous lecture. Actually, stable storage is a kind of storage which does not suffer from system crash. Means even if the system crashes, even if the power failure occurs, then also the content of the storage will never be lost. So once the log record has been created, that log record is generally kept on a stable storage. Now the thing is that log records have some following fields. For example, the first field of the log record is transaction identifier. Means in every log record, following set of component will be there. The first is the transaction identifier. It is the unique identifier of transaction that perform the write operation. Means whenever a transaction initiated, then every transaction has been assigned a unique identifier, and that is known as transaction identifier. So whenever a transaction performs the update operation or write operation, then that particular transaction's identifier has been recorded in the log. Next, data item identifier is the another component which is unique identifier related to the data item on which the updation has been performed by transaction. Typically, data identifier can be used as the location on the disk of the data item. The third most important attribute or the third most important component of the log is the old value field or old value component. Old value is basically the value of the data item prior to the write operation. Means before transaction perform the write operation, the initial value of that particular data item are stored in the old value attribute or old value component. Next, new value, it is the value that the data item will have after the write operation. Means once the transaction perform the processing and transaction will perform the write operation. After the write operation has been done, what will be the value, what will be the new value of that particular data item that will be designated as a new value field. So basically these are the main field or main attribute or the main component of any log. Let's take an example how log records looks like. So let me mark it. So whenever a transaction starts its execution, then log record automatically has been maintained. And when transaction starts, at that point of time, within a log, that particular record will have been recorded. So it can be represented in that form TI start. So what is the significance of that line? That means transaction TI has been started. Next, whenever transaction TI performs the write operation on a particular data item, then that write operation has been represented in the log with that particular format. Now, what is the format? Here, TI is the transaction identifier, means transaction TI, performing the write operation or the update operation on the data item xj. V1 is the old value, means the value prior to the transaction executes, and V2 is the new value, means the value which will be assigned to xj once transaction has completed its execution successfully. So for every write operation by a transaction, that particular record is to be recorded in the log record. So that means transaction TI, which is perform the write operation on the data item xj, whose old value is v1. Old value means the value prior to the transaction execution, and v2 is the new value which is going to be assigned on xj after transaction completes successfully. Next, once the transaction has been executed, all of its statement, all of its instruction, that means transaction has been committed, and that record has to be maintained in the log in the format of TI commit, means transaction TI has been committed. Now, if somehow transaction not able to commit, then it will record TI abort. So this is basically the log. That is how a log is looks like. So this is the log record. Now, once the log record has been created, all this the log record file are assumed that this log record are directly written to the stable storage. And the thing is that for every when these are the individual record, this is the one record, second record, third record, fourth record. Each record actually specify the status. And for every whenever the every status has been recorded in the log, every time they are directly written on the stable storage. They are not buffered, they are directly written in stable storage instead. Now, based on this log based recovery, we have two approaches for recovery technique. One is deferred database modification and immediate database modification. Means these two are the approaches of recovery technique, and in both these approaches are based on log. Means deferred database modification and immediate database modification, the two recovery management technique which is based on log based recovery. We will discuss it here. So first we will discuss about the deferred database modification. Now the first thing, deferred database modification is a log based recovery technique. In deferred database modification technique, it records all the modification to the log, but it defers all the write operation to after partial commit. What does it mean? In that scheme, every updation related records or every activity of the transaction are recorded in the log file, and log file once is created, the log file is stored in the stable storage, but whatever the updation or whatever the write operation has been performed by the transaction, they are not immediately outputted to the actual database. Rather, actual output to the database has been deferred, means they are delayed. That means once the transaction performs the write operation, it does not output the actual content to the database immediately. Rather, in that scheme, it will defer the write operation. That means the actual output of the write operation to the database will be delayed until and unless the transaction partially commits. Partially commits means once all the instructions of a transaction has been executed successfully, then we count it as a partially commit. So once transaction enter into the partial commit, then only we perform actual write operation. Means then we perform all the output to the database. It will be much more clear if we discuss it with an example in the next slide. So the basic thing is that, again I'm repeating, for every activity performed by a transaction, all has been recorded in the log, and log are immediately have been written to the stable storage. But whatever the write operation has been performed by a particular transaction, the immediate write operation has not been performed, means the output of the write operation not been updated on the database immediately, rather they are deferred, rather they are delayed until transaction commit partially commit. Once transaction partially commits, then whatever the write operation it has been performed, all the output of the write operation has been updated on the database. Once the transaction partially commits, and we write or the will output that write operation to the database with the help of log. How it will be happen, we will see it in next slide. Now transaction starts as usual in the log in database default database modification also. Whenever transaction starts, we will enter a record in the log in that form ti start. Means it indicates that transaction has been started. Now another very important point here is that what we have seen in the last slide, whenever write operation has been done, a record has been recorded in the log, which is in the form of transaction identifier, comma data item name on which it has been updating, next comma old value, comma new value. But in default database modification, for update operation or write operation, a log record has been inserted, but the format is a bit different to the previous one, which I have been discussed in the last slide. Now here, this is the in that form will be inserted. This is the transaction identifier, comma database name on which write operation has been done, and only we are using v. V means the new value. So this is transaction identifier ti. It performs the write operation on x, and we are maintaining the new value. Means the value which is going to be assigned on the data item x after transaction completes successfully. So here one thing is missing is the old value. In default database modification scheme, old value is not required in this scheme. Why this is not required, I will tell you with an example. Next, the write operation is not performed on x at this time, but is deferred. But I have actually already been telling that for write operation, whatever the write operation transaction has been performed, it does not immediately output of the write operation to the actual database. Rather, output will be deferred. Means actual modification to the database for the write operation has been deferred, has been delayed. It will delay until it partially commits. So when ti partially commits, ti commit has been recorded in the log, and once transaction ti enter partial commit status, then only the system will perform all the output of write operation to the actual database, which was delayed at that point. Now finally the log records are read and used to actually execute the previously deferred writes. In the next slide, we will take an example. Now before taking an example, another important point is that now suppose transaction fails during execution time. That means we have to recover from it with the help of deferred database modification technique. So during recovery, after system crash or transaction failure, the transaction needs to be redone. This transaction needs to be redone if and only if both TI start and TI commit are in the log. Means once the transaction has failed, once the system has been crashed, so when we restart the system, then we'll again re-execute, we will again redone the transaction if we get tstart and tcommit record in the log. That means once the system has been restarted, we need to consult the log record. And in the log record, if two entry are there, TI start and TI commit, that means we, we have to redo it. Why? Because from TI start we can make sure that transaction has been started, and if TI commit is there, that means transaction is committed. That is why TI commit is recorded. So transaction is committed, so that means database needs to be updated. So we have to redo. For redone, we have to execute the command redo TI. Redo TI means it will set the value of all data item updated by the transaction to the new value. Redo TI means it will update all the data item with the new value. Now the crashes can occur. As the system crash can occur while transaction is executing the original update or while the recovery action is being taken. Now consider the example. Suppose two transactions are executing and two transactions are executing in serially, not in concurrent manner. So transaction T0 and T1, and T0 executes first, then T1, and T0 transfer $50 from account A to account B. And transaction T1 subtract $100 from account C. So consider these two transactions and let's see how system crash, how we recover from the system crash with the help of deferred database modification. As I have mentioned that already, T0 will execute first, then only T1 will execute. That means they are going to be executed serially. So let's see how the log records are actually maintained. So when T0 starts, a record T0 start has been recorded in the log, and this is the database part, this is the log part. So in deferred database part, database is not going to be updated at all until and unless transaction enter into the commit section. So after that, if you remember, the transaction, what it has done, it read the content of A and then deduct the $50. Suppose the content of A is $1,000 and content of B say $2,000. So in the previous transaction, what we have seen, transaction T0 deduct $50 from account A. So that means A is equal to A minus 50, then write A operation. So write A operation means it is not immediately is going to update the database. Rather, for that update operation, a log has been maintained, and this is the log record is maintained associated with the updation on the A. So T0 is the transaction which perform the write operation on A, and after deducting $50 from A, the new value will be 950. So if you look at the database section, database part, no updation has been done yet. Means though the write operation has been performed, but no updation has been done on the database. Rather, the record has been created and inserted in the log record for that particular write operation. Next, what we have seen that transaction T0 reads the content of B, then add the $50 to B, means read B, B is equal to B plus 50. That means it writes the, and then it performs the write operation B, write B. So content of B was 2000. After addition of $50, it will become 2050, and then it writes B. But if you look at again here the database part, no updation has been done in the database immediately. Rather, a record has been inserted in the log record. What is that? Transaction T0 perform write operation on the B. The new data value on the B will be 2050 after addition of $50 over here. So that record only maintained in the log, but no actual updation has been done on the database for the write operation. Though write operation has been done, but no actual databases are updated. Rather, only log record is maintained. Now, since all the instruction has been completed its execution, for that transaction insert a record which is T0 commit. So T0 commit is the once all the instructions of a transaction are executed successfully, then the T0 commit status has been recorded in the log. Now at that point of time you can tell that the transaction T0 has been partially committed. So partially committed means once all the instruction of transaction executed successfully, then we will record T0 commit, and at that point of time we can tell that transaction T0 has partially committed. So once transaction has been committed, then only the database modification has been occurred. Means at that point of time, operating system will initiate all the output to the database. Now database here A and B. So all the database modification has been delayed or deferred until transaction commits. So once transaction commits, now actual updation has been done in the database. So A here has been modified 950 and B is modified to 2050. Similarly, for then once T0 has been completed, T1 starts its execution. So once T0 completed, then T1 starts. So once transaction T1 start executing, then what happened? T1 start, that status has been inserted in the form of T1 start. Then if you remember, transaction T1 deduct 4000 rupees. Suppose the content of C say 1000 rupees, and if it deducts $400, then it will be T1 C 600, means transaction T1 perform the write operation C and the new value will be 600. But if you look at the database part, no actual updation has been done on the database. Then as all the instruction of the transaction T1 has been completed, so T1 commit is recorded. Now once T1 commits, that means T1 enter in the partial commit status, then actual database modification has been done. Means operating system then will initiate the output operation on that database. Then the actual database content will be modified with 600 after deduction of $400. So this is the concept of deferred database modification, where the actual output of the write operation has not been initiated immediately, rather they are delayed or deferred until and unless transaction partially completes. Now let's look at how we can recover after the failure of a transaction with the help of deferred database modification. Consider the same example. Suppose we are executing two transactions, transaction T0 and the transaction T1, and we are assuming T0 and T1 are executing serially, first T0 then T1. So as I have mentioned in the deferred database modification, for every activity of the transaction, every activity record are inserted in the log record. Now these are the three different log records. Just consider only this one first. Only consider this one, not B and C. Only concentrate on A. Suppose this is a single log record. Now suppose transaction T0 has been started by the system. So what happened? T0 start record has been recorded in the log because T0 started. Then T0 read the content of A, means it transfer the content from hard disk to RAM. Then it will deduct $50. Suppose the content of A is 1000. So it will deduct the $50. So whatever the updation, it will be updation on the RAM, not in the hard disk. Then it will perform the write A. So in deferred database modification, though write A operation has been initiated, but actual updation, actual data updation on the hard disk is delayed. Not it will happen immediately. But for write A operation, that activity will be recorded with the form of T0A950. T0 is the transaction performing the write operation on A, and the new value will be, after deducting $50, it will be 950. Next, suppose transaction execute read B, it has been updated B, and then perform write B. Though write B has, and after write B, suppose transaction fails. At that point of time, suppose transaction fails immediately. So as the write B operation has been executed, that is why this activity has been recorded. Transaction T0 perform write B operation, and after modification of the database, then suppose B is 2000. So after adding $50, it will be 2050. But assume that transaction crashed immediately after write B operation, we have we yet to add the commit record here, but as system crashes immediately after write B, so we are not able to write the commit comment here. T0 commit is missing, so system has crashed. So what happened when we start again, means when we restart our system, what we have to do, we have to consult that log record only. Why? To check whether a particular transaction has committed or not. So we have to consult the log record, only that record. So after consulting log record, we have found T0 has started, but no commit was there. That means from that log record, we can implies that though the transaction was started, but it was not able to complete this execution. So in that case, what happened, as transaction has not committed, so what we'll do, only we'll delete the log record associated with T0. And if you look at, as the immediate effect of write has been not done on the database, so database was still consistent, no updation has been done on the database, so database has not been updated, so database will always be in consistent state even after system is failure. But if transaction successfully completes, then we'll see it later though. So as there is no commit, that means we pretend that transaction was not completed successfully. So that is why database was not been modified. So what we will do, we simply delete the log record. So no redo action needs to be taken. No redo is to be taken. Now consider this one. Suppose transaction T0 perform the read operation, start the operation T0 start, then perform the write operation on A. So this is recorded. Then it performs the B write B operation. So that activity is also recorded. And suppose T0 successfully completes all the instruction. So that means transaction enter into the partial committed step. So T0 commit statement has been recorded. So T0 commit recorded means T0 has been partially commit. Why we term it partially commit? Because although all the instructions have been executed by the transaction, but still all the output of write operation has yet to be updated on the database because they are delayed. So once that commit has been done, commit of the transaction T0 has been done, then operating system will initiate the output of write A and write B to the actual database. So in the meantime, that is going to be initiated by the operating system, and at the same time, as the T0 is completed, T1 started. So what happened? T1 start will be recorded. Suppose T0 perform the write operation, so that activity is also be recorded. Now suppose that at that point of time, immediately after the write operation, transaction system has been crashes, system failure has been done. So what happened? T0 commit yet to be recorded but not recorded yet. So that is why once the system restart again we have to consult a log record. And after consulting the log record, what we have found that we have to consult that record only. This is the log. This is the log record maintaining for the second example. So once we consult the log record, what we have found that for transaction T0, that T0 start is there, means T0 started. Then we also find T0 commit, that means T0 also was committed also. So that means once the system restart, what we have to do, we have to perform the redo operation. Then now we have to perform the redo operation for transaction T0. Now redo operation means what I have said earlier. Redo means it will set the content of the database with the new updated value. Redo means whatever the update or whatever the write operation has been done by the transaction, all the data items have to be set with the new value. So this is what called redo. Now how to perform the redo operation? Again with the consulting with the log record. Let's see how. So we have to first we have to perform the redo. Why? Because T0 started, T0 committed. So we have to perform redo operation for T0. Redo means we have to update every data item with the new value. Now new value has been recorded in the log. So new value of A is 950. So operating system will write 950 to the actual database A. New value of B is 2050. We have seen from log. So that value is also be updated on the actual database. That is how redo operation has been done. And if you look at the log record, T1 start record is there, means we can pretend that T1 started, but no T1 commit was there. So that means that implies that though T1 started but was not able to complete execution successfully. So in that case, the database updation by the T1 has not been affected. So no need to redo operation for transaction T1. Simply we have to ignore the T1 transaction. Now consider the third case. Suppose both the transactions T0 and T1 both are successfully completed. So consider this one. So T0 start is there, T0 A 950, write A operation has been performed, write B operation has been performed, T0 completed successfully, so T0 commit is there. Next T1 start, then T1 perform the write C operation, so T1 C600 is there. Then T1 also completed successfully, so T1 C commit is also there. And after that, suppose once the commit has been done, after that, suppose system crashes. So what may happen that actually operating system will initiate all the output to the write operation into the database. So during that output of write operation to the database, it may happen that system may crash. So in that case, what happens when restart, we have to consult that particular log, and from log we can see that T0 and T1 both has been committed. So again, what we have to do, we have to perform the redo T0 and redo T1. So in that case, for both the transaction T0 and T1, we have to perform redo operation. So in redo operation, what operating system will do, it will read the log record and it will update the database A with the new value. So it will update the content of A with the new value 950. It will update the content of B with the new value 250. It will update the content of C with the new value 600. So that is how we can use deferred database multiplication for recovery. The next the next log-based recovery technique is immediate database modification technique. So again, immediate database modification technique is a recovery technique based on log-based recovery. As the name implies, immediate database modification. From the name itself, we can sense that whenever the transaction executes the write operation, the output of that write operation has been immediately performed on the database. That means the output of the write operation has not been delayed till the transaction partially commit. Rather, in immediate database modification, whenever transaction performs the write operation, the output of that write operation on the database immediately. The operation has not been delayed. But thing is that, like deferred database modification, in immediate database modification also the log has to be maintained for recovery purpose. That means whenever transaction do any kind of activity, so for every transaction, that log activity log has to be maintained, log record has to be maintained. But the structure of log record is a bit different with the log which was maintained by the deferred database modification. We'll see it later. And in the immediate database modification, what I have tell, when the transaction has not been committed yet, still we can update the database. Means still database, still a transaction is in active state. It has not been committed. Still that during that time also we can update, we can output the write operation in the stable storage of the hard disk. So that is why this is also called uncommitted modification. And another important, so the difference what I have said with the deferred and immediate is that the structure of log is bit different with the deferred database modification. We'll see it, let's see it later. Another difference is that in case of deferred database modification, whenever the system crashes after consulting log, only we have to do only we have to redo the transaction or just ignore them. But in immediate database modification, we have to perform either of the two operations. Either we can perform redo operation or we can perform undo operation. So what is undo? That will be discussed later. Now, another important point about the immediate database modification is that the updation of log record must be written before database item is written. What I have said that whatever the transaction perform the write operation, it immediately output the write operation to the hard disk. But before doing that, log record has to be created, and that log record has to be redirected to the stable storage. That means before actual output of the write operation to the hard disk, log record has to be maintained and log record has to be directed to the stable storage directly. And after the log record has been recorded on the stable storage, then we can perform the updation on the actual database. And the output of update block can be take place at any time before or after transaction commit. What I have already tells that output of update blocks can be take place at any time, either before transaction commit or after transaction commit. And the order in which the blocks output can be different from the order in which they are written. That means it is not a it will not operating system is not going to maintain the order of updation the way there has been written. Now let's see how the log record has been represented in immediate database modification technique. But I have said earlier that the log record, the structure of log is bit different with the deferred database modification. So let's see. Consider again two transactions T0, T1, and they are going to be executed serially. T0 followed by T1. Suppose T0 started first. So what happened in the log? T0 start activity has been recorded. Then A is equal to A minus 50 means modification has been done on the data item A, but the modification has been done not in the hard disk, so that it has been done on the RAM. And then it perform write A. So suppose the content of A is 1000, so it's 1000, and B is 2000. Now write A has been done. So the moment write A has been done, it will first record the activity to the log record. Now if you look at the structure, it will bit difference with the deferred database modification. This part is new. Here, what is the significance? Transaction T0 performing the write A operation, and 1000 is the old value 950 is the new value. So this is the new value what we are also using the deferred database modification, and this is the old value what we are using here, as well as then it will read the B, then perform modification, then perform write B. So another activity has been recorded. Again, this is the 2000 is the old value, 2050 after modification it will be the new value. Here important part, if you look at the database now, transaction has not still committed, but still we are updating the database. Means after T0 executing write A, first thing is to be record that write A activity to the log, which is this one. Then you can start the database modification here also. Means here you can write A is equal to 950 also. This is same. If you write it here or here is more or less same. The main thing is that the database modification is to be before T0 commits. Similarly, the moment you are transaction or executing write B, first thing has to be done is to maintain that activity into the log. Then after that you can start output the content of B into the actual database, but before T0 commit. So in immediate database modification, difference is that the updation to the database has not been delayed to till the commit, rather they are performing before the transaction commits. Means when the transaction is in active state, then also we are able to update the database. Then once the database has been updated, then T0 enters the commit state and it records. Similarly, T0 and T0 commits, T1 will start, so T1 start, then modification has been done, so the record activity record has been maintained here. Transaction T1, write operation on C, 700 is the old value, 600 is the new value, and write operation once the log record has been, after the write operation, once the log record has been maintained, and immediately then database has been updated, and then once updation has been done to the actual database, then T1 commits. So these are the basic two differences of immediate and deferred database modification. In immediate modification, apart from new value, we have to maintain old value for any write operation. This is the one difference. Second difference, the actual database modification has been done before transaction commits. Now, how to recover from transaction failure, system failure with the help of immediate database modification is that we have to perform either of the two operations, undo and redo. But in deferred database modification, what we have done only redo. But here we have two options. Either we can perform undo or we can perform redo. So when we will do undo operation, undo of first, what is undo? Undo means restore the value of all data item updated by transaction TI to their old values. Means going backward from last log record. Means undo means is nothing but restoring all the data item prior to the transaction starts. Redo is just opposite of undo. Redo means it sets the value of all data item updated by transaction TI to the new value. Means once the transaction has been successfully committed, we have to set the data item with the new value after completion of the transaction. And thing is that both operations are idempotent. Idempotent means even if we perform undo or redo operation multiple times, their effect will be same as if they are executed at least once. Now, whenever transaction fails due to any kind of failure, then how to recover? For that, the transaction first when starts, T1 start will be there. If transaction commits successfully, TY commit will be there. So what we have to do, we have to consult the log record. And after consulting the log record, if we found that TI starts is there, TI start is there in the log, but TI commit is not present. But means TI start is there, but the log record does not contain TI commit. So what we can pretend is that T1 was started but was not able to complete it successfully. That means, as it is immediate database modification, that means some of the data item may have already been modified, and as it is not committed successfully, some of the data item are still unchanged. So some of the data item has been updated, some of the data item has not been updated. So to ensure the atomicity and the consistency property, what we have to do, we have to restore the database to the previous state. For that, we have to perform the undo in that case. So again, I am repeating: if the log record contains TI start but no TI commit is present in the log record in case of immediate database modification, then we have to do the undo operation. But what happens if we consult the log record and if we find TI start and TI commit? Means in the log record it contains both TI start and TI commit. That means it was started, it was committed successfully, but somehow it has failed. So that means we have to redo the operation. Redo means we have to we have to store the database with the new value, the updated value. And one thing is, undo operation are performed first, then we have to perform the redo operation. Let's see how recovery can be performed with the help of immediate database modification with an example. Consider the same transaction T0 and T1 that executing serially. Again, this is the log, three separate logs for three scenario. First consider this one. Suppose T0 started, so T0 start record is being recorded, then it performs write A operation. So in immediate modification, what happened? The moment write A is executed but in that transaction T0, but at that moment that activity has to be recorded in the log. So T0 data item A, this is the old record, this is the new record. And then actual output of the write A operation has been performed on the database, has been started. Output of A has been transferred to the actual database. Next, it performs read B, then perform the calculation, then write B. The moment it executes write B, the activity has been recorded. Transaction T0, data item B, old value 2000, new value 2050. Suppose assume that if the moment after write B, at that moment, immediate after write B, transaction fails. Means transaction is not able to complete execution. So T0 commit is not there. So system fails. So again, when we restart the system, then first we'll consult the log record, and from that what we get, T0 start is there, T0 commit is not there. So that means we can conclude that T0 was started but was not able to complete successfully. But as this is the immediate modification, that means some of the data item are already being modified, some of the data item are not modified because it's immediate modification. So that means some data item are already been modified and some data item are yet to be modified. So what happens? Database become inconsistent state. As well as to ensure the atomicity and the inconsistency property, in that case what we have to do, we have to undo. So this is the case one, we have to undo the transaction T0. Now consider the second case. Consider this one. Suppose T0 has been successfully completed, means T0 committed. So while T0 started, record is added. Then for write operation, this is added. For write B operation, this has been recorded. And then T0 commit. Then T1 start. Then assume that T1 initiated write C operation. So the moment it initiates write C operation, what happens? That activity will be recorded and operating system will initiate the output of C to the hard disk. Operating system will transfer the content of C from RAM to the hard disk immediately. But assume that immediately after write C, T1 fails, not able to complete its execution. So in the log, T1 commit has not been recorded. So once we restart, what we have to do? We have to consult the log record. And from the log record, what we have seen that T0 start, T0 commit are there. So that means T0 was completed successfully. So for that, for the transaction T0, we have to perform the redo operation. And from log, what we have seen that T1, though T1 has been started, but no T1 commit is there. So thing is that T1 was not able to complete the execution successfully. So we have to perform the undo operation. So undo means whatever the data item T1 has been updated partially, all the data item has to be restored with the old value. Here the old value of C is 700. So undo operation will restore the database C with the old value 700. Redo means whatever the data item T0 has been updated or performed right, the data item is going to be updated with the new value. So T0 has been used A and B, so A and B will be updated with the new value 950 and 250. Now consider the third case where both T0 and T1 both have been completed successfully. So in both the cases, T0 start, T0 commit are there, T1 start, T1 commit are there. So even if after completion of T0, T1 system has been crashes. So when we restart, we have to consult the log record. And from the log record, what we have seen that T1 and T0 and T1 both have been completed successfully. So for both the cases, we have to perform redo operation. So that is how we can recover system crash with the help of immediate database modification. So the next topic is checkpoint. So whatever we have seen earlier is that whenever a transaction fails to complete its execution, and once the system restarts, so first we have to consult with the log record to determine whether a particular transaction has to perform undo operation or redo operation. That is why we have to read the entire log record. But there is a disadvantage is there. Disadvantage we have to search and read the entire log record, which is time consuming. Also, we might unnecessarily we perform redo transaction, but which already have been done. Means some transaction failed, but still suppose there all the output operation have been done in that meantime. So when transactions start again, we are redoing the same thing again. So this will create an overhead. So this is the basically the overhead which is associated with the log-based recovery. So for that, to reduce the overhead, we are introducing the concept of checkpoints. Actually, in the checkpoint concept, we have to consider three things. First, output all log records. Means all the log records, we have to output all the log records. Those are currently in the main memory onto the stable storage. Means first, whatever the log record has been maintained in the main memory has to be copied back into the stable storage. Second, output all modified buffer blocks on the disks. Next, all the write operation has to be updated on the hard disks. And once it is done, then we have to write a log record checkpoint on the stable storage. Means when the first and second operation has been done, we have to add a record checkpoint in the log record. So in the form of checkpoint command, we have to add this command into the log record, and that has to be again transferred to the stable storage. So these three procedure we have to follow in the checkpoints. Now during recovery process, what we need to consider only the most recent transaction TI that started before the checkpoint and the transaction that started of the transaction TI. Suppose the transaction fails. So when we restart the system, what we have to do, we have to generally used to read the whole log file. But in that case, we have to scan, we have to read backwards from last end of the log file, from the very last line of the log file to the backward direction. Means suppose this is the log file, This is the checkpoint C, and this is the last line in the log record. So what we have to do, we have to read from last line and we have to read backward direction, and we have to find the most recent checkpoint. Suppose this is the most recent checkpoint. Now continue scanning backward till a record TI start is found. Need only consider part of log following above start record. Earlier part of the log can be ignored. And for all transactions, suppose say TI with no TI commit, we have to execute undo operation. So when we have to undo, we have to, again I am repeating, we have to read it from last last end of the log record to backward direction up to the most recent checkpoint. Whenever we find the checkpoint, then again we continue to read the part which is above the checkpoint. Then in the meantime, if we find the TI commit, then what we have to do? We have to undo the transaction. And just along the step, from above the part of checkpoint, if we don't find the TI commit, no TI commit is there. That means transaction TI is not committed. So we have to execute undo. But if we find TI commit, that means transaction was committed. So we have to perform the redo operation. So that is how we can reduce the overhead with the help of checkpoint. So that's all for today, and this is the references which you can consult for more clarification.